In this section, we're looking at expanding powers of binomials using Pascal's triangle. So what is Pascal's triangle? What we do is you start with a 1 in our top row, and we follow our next row with other 1s. Now, as we move down in the triangle, it's going to be the sum of the two values above it. So in between the 1 and the 1 is a 2, because 1 plus 1 is 2. And we put 1s on the outside. So we go again, we get 1, 3, 3, 1, where the 3 is the 1 plus 2 or the 2 plus 1. Moving down we get 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. We'll go one more row, we get 1, 7, 21, 35, 35, 21, 7, 1. Now a few things you may notice about the triangle. It's symmetrical, it's the same thing on opposite sides. We have 1s going down the outside of both rows, and we are adding to them. You're going to start seeing other patterns as we go through there. So for example, one of them is that we have the 1, 2, 3, 4, 5, 6, 7 as all our values there. We said it was symmetrical earlier. There's other patterns we could look there if we needed. Now let's focus on identifying. So we're going to call this row 1, 2, 3, 4, 5, 6, 7, and row 8. Now, it could go on infinitely and we could have many, many, many rows, but we're going to really focus on the first 8, because if we needed to go further, we could go further and we keep expanding it out, but we can get a lot out of the first 8. Now, what does this triangle have to do with binomials in different powers? Well, let's talk about a basic binomial. Let's say we had x plus y squared. So our binomial is x plus y, and we're squaring that. If you were to square that, you would have gotten x squared plus 2xy plus y squared. Which, okay, well what does that have to do with this triangle? If we rewrite the coefficients, we get 1x squared plus 2xy plus 1y squared, which is actually what we had in row 3. If you look at row 3, that's 1, 2, 1. It's coefficients. Okay, let's do another one. If I had x plus y to the third, basically I've taken x plus y squared and now I'm multiplying it by x plus y. I could have done FOIL or a box method or whatever method you want to use. And again, this is now x plus y times what we did above. Okay, this comes out to be 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed. Now, what is it this time? Notice that's what row 4 is. Okay, well let's see if we can figure something out here. What if we now wanted x plus y to the fourth, but I didn't want to have to multiply? So let's see. I know my coefficients would be 1, 4, 6, 4, 1, because it's the next row. We take the row and one less than that. So row 5 fits to the 4th power. Now, if I look at the ones I already done, I always seem to start my exponent to the power on the outside. So that means this would be x to the 4th, then 4x to the 3rd, because it kind of keeps going down and down, x squared, x, and then, well, I don't have an x there. Well, it's kind of like x to the 0. It would just be 1. Okay, so now we need the y. Well, we don't have a y in the first one, which is kind of like saying y to the 0, if we think about it. Plus 4x cubed, I'm going to guess a y to the 1, then y squared, then y to the 3rd, and then it ends with y to the 4th. Almost a mirror image of the x's. The x's went 4, 3, 2, 1, 0, the y's went 0, 1, 2, 3, 4. Well, we could then sit there. What if I now wanted to say, with that in mind, what if I wanted x plus y, not 7, x plus y to the, let's go 7th. So if it's the 7th, it means I'm probably going to go row 8. That's like a one more. In row 8, I had 1, 7, 21, 35, 35, 21, 7, 1. Those are my coefficients. So let's kind of see if we can fill it in order. So 1 is my first one. Then it's going to be x to the 7th. I didn't have a y in the first one. It's like y to the 0. Then I'm going to do 7. That's my next coefficient. 1 less on the x. Then we introduce y to the first. Then 21, 1 less on the x, 1 more on the y. Then 35, 1 less on the x, 1 more on the y. Then another 35, 1 less on the x, 1 more on the y. Then we're going to go 21, 7, and then the last one is 1y to the 7th. So really, with this idea, I could just get any binomial, maybe something a little more fancier than x plus y, and I could figure out what each terms would be. Now, maybe you're looking at this going, why do we need to do this? What if I really gave you x plus y to the 7th? And instead of knowing how to do Pascal's triangle and this expansion, you would have had to do x plus y times x plus y times x plus y times x plus y times x plus y. And it just gets longer and longer and longer. It's multiplication after multiplication. You'd be really doing 6 different polynomial multiplications. It would take a while. This is going to be faster for us. So let's look at the rules that we have. I would recommend copying the triangle down, though, and so you have something to reference. So if you need to pause the video, copy down the triangle because we will refer to it often in this video. Binomial theorem says to expand a binomial to the form a plus b to the n. So we have one term plus another term to some power. We will use the n plus 1 row of Pascal's triangle to find the coefficients. So I take my a plus b to the n, and I use the n plus 1 row. So if n is 7, I use row 8. If n is 4, I use row 5. That's the idea we have. Okay? The terms, not including the coefficients, so these are these a's and b's, what we did with x and y, will be of the form where each is a to the n minus r, b to the r. Well, let's kind of look with the process, because really we could write the notation, but let's look at what we did. We always start with the same exponent on the a that the binomial was, so it was to the n. So we start with that one, and b is to the 0. And as we move down, a's exponent, let's write that better, the exponent on a gets less, while the exponent on b increases. I guess we should say decreases instead of gets less. We should be proper here. Decreases. So eventually, when we start, it's b to the 0, a to the n, and at the end, it will be a to the 0, b to the n. Now, another thing you may notice here is that the exponents of a and b always have to add to n. So if it's to the 5th, no matter what term I look at, when I write this out like that, it should be the exponent of a, exponent of b should add to the 5th. Well, let's look back at the ones we had. When we had to the 4th here, well, let's go down to the bottom one. When we had to the 7th, I had 5 and 2, 4 and 3, 3 and 4, 2 and 5, 6 and 1, 7 and 0. It always added to the 7th. And that's something that may help you as you go through with them. Okay, let's do some examples. so now we need to find a few things in this. We need to find the number of terms in each one and what the first term and last term would look at. Eventually we're going to build it up and look at them, but this is kind of a good start for us. So the number of terms. Well, if it's to the 6th, we know we're going to use row 7. Well, let's jump back and see how many terms row 7 had. So row 7 had 1, 6, 15, 20, 15, 6, and 1. It had 7 terms. So we could even say the number of the row it's in is the number of terms it would have. Now, you may think, well, we start with a to the 6th and we go down from there. Isn't it 6 terms? But we have to remember we do actually have an a to the 0 at the end. So we go from 6, 5, 4, 3, 2, 1, 0. So you will always have one more term in the expansion than the exponent you start with. Okay, so we had 7 terms, and let's look at the rest of them. If I had to the 5th, that's row 6, so that means 6 terms. If I had to the 7th, that means row 8, and that means I have 8 terms. Okay, now let's look at the first term. So the first term we know would start with, well, first term and last term always have a 1 by Pascal's triangle. That's always our first and last values. So I know it's going to start with 1 a to the 6th, negative b to the 0. Well, negative b to the 0 is just 1, so my first term is 1 a to the 6th, so it's actually just a to the 6th. So first term is a to the 6th. And then I'd go plus, I'd add a whole bunch of stuff, and I'd get to the end, I have a 1, a to the 0, negative b to the 6th. Well, a to the 0 is 1, 1 is 1, negative b to the 6th. Really I want to pay attention to the negative. Since it's an even exponent, the negative becomes positive, so that becomes b to the 6th. And that's my last term. Okay, 4x plus y to the 5th. We're going to look at first term. It's going to be 1's the coefficient, and then it's 4x to the 5th. So 4 times 4 to the 5th, x to the 5th. If we do 4 to the 5th, that is 1024 x to the 5th. So there's our first term. Then we add a whole bunch of stuff. We get to the end, and it's going to be y to the 5th, which is just y to the 5th. So that's our last term. Now keep in mind here, we normally, if we're not on the first and the last term, we have to pay attention to coefficients, but since it's the first and last term, the coefficients are 1. Okay, a minus 2 to the 7th, I have a to the 7th is my first term. And then we go on through there. We get to the end. It would be negative 2 to the 7th. Negative 2 to the 7th. Well, 2 to the 7th. Let's figure that one out. Looks like we have 16 times 8, which is 128. So 2 to the 7th is 128, but it's a negative 2, and it's an odd number, so it's actually minus 128, and that's going to be my last term. So pay attention to those negatives. If you get an odd, they're going to stay negative. Okay, let's do a couple more. Well, I guess now we're going to expand the whole expression. So not just first term, last term, we're going to put it all together. So first thing I want to look at is 5 as my exponent, so I'm going row 6. If I want to then write out what maybe my coefficients are, just to give you an idea of where I'm going, I got 1, 5, 10, 10, 5, 1. So those are my lead coefficients. So let's start it off. Here I got 1, x to the 5th, y to the 0. I'm not going to write that, it's just 1. Then I go 5, x to the 4th, 1 less, y to the 1st. plus 10 x to the third y to the second plus 10 y to the second, or x to the second y to the third plus 5 x to the first y to the fourth plus 1 x to the 0, we're not going to write that, y to the fifth. Okay, we can now put it together. We get x to the fifth plus 5x to the fourth y plus 10 x to the third y squared plus 10 x squared y to the third plus 5xy to the fourth plus y to the fifth. Okay, and there's our expansion. Notice in each one the exponents do add up to 5. Okay, let's go down to now x plus 2 to the third. So it's to the third, so we know row 4. If I look at my row 4, it's 1, 3, 3, 1. So I got 4 terms. So let's kind of write it out. We got here. We got 1 x to the third. Remember, it's not to the fourth because it's always the most it can be is that x to the third times, we'll write it this time, 2 to the 0. Next coefficient is 3, x squared, 2 to the first. Next one is 3x to the first, 2 squared. And the last one is 1 x to the 0, 2 to the third. Now, this one's different because it's not just x and y. We have a 2 here, so we won't actually have the exponents. But right now we can kind of see we have 3, 0, 2, 1, 1, 2, 0, 3. They do all add up to 3. But I'm going to simplify out here. I get x to the third. Now, 3x squared times 2 becomes 6x squared. 2 squared times 3, that's 12x. And then 2 to the third is 8, so that's plus 8. So there's our expansion of x plus 2 to the third. Okay, let's add a little bit more to it now. So 2x minus 3 to the fourth. I see the 4, that tells me row 5. The highest exponent is 4, but I'm going to have 5 terms. My coefficients are 1, 4, 6, 4, 1. So here we go. We start with 1 times 2x to the fourth, negative 3 to the 0. 4 times 2x to the third, negative 3 to the first. 6 times 2x squared, negative 3 squared. Plus 4 times 2x to the first, negative 3 to the third, and then plus 1, 2x to the 0, negative 3 to the fourth. Okay, let's start piecing it together. Well, negative 3 to the 0 is 1, so I don't have to worry about that one. 2x to the fourth, 2 to the fourth is 16, so I have 16x to the fourth plus, well, I have 4, 2x to the third, and negative 3. Well, 2x to the third is 8. Let's kind of move this around here. Let's move that down. So it's really going to be 4 times 8x to the third times negative 3, which is 32x to the third times negative 3, which looks like it's not actually going to be positive, it's going to be negative 96x to the third. Okay, move to our next term. I have 6 times 4x squared times 9. That's 24x squared times 9. Let's do our scratch work off to the side. 24 times 9 is 216. So that becomes 216x squared. Moving on, we have 4 times 2x times a negative 27. So this is 8x times negative 27. If we do 27 times 8, We also get 216. And our last one, it's going to be 1 times 2x to the 0, which is 1, times negative 3 to the 4th. That will be 3 to the 4th is 81, so plus 81. We have no x there because we've counted down our x to 0. One last thing we noticed there was we have the 216 to the x. That was a negative, so we need to make sure there's a negative there. Hopefully you saw that. So hopefully by now it's making some sense. If you want to start looking at the homework, you can and start working your way through them, but I'm going to do a couple more examples. I have 2x minus 1 to the 7th. 7 is my exponent, so I think row 8. For row 8, I go 1, 7, 21, 35, 35, 21, 7, 1. We can start to see these numbers are going to get very large with the further rows we have, especially if we have coefficients inside the binomial, like we have with 2x here. So let's write it out. We're going to go 1 times 2x to the 7th, then that's times negative 1 to the 0, plus 7 times 2x to the 6th, negative 1 to the 1st, plus 21 times 2x to the 5th, negative 1 squared, plus 35, 2x to the 4th, negative 1 to the 3rd, plus 35, 2x to the 3rd, negative 1 to the 4th, plus 21, 2x squared, negative 1 to the 5th, plus 7, 2x to the 1st, negative 1 to the 6th, and we almost ran out of space there. Last one is 1 times negative 1 to the 7th. Alright, so let's start putting this together. First we have 2 to the 7th. 2 to the 7th is 128, so that's 128x to the 7th. Then we go down to the next term. 2 to the 6th is 64. So x to the 6th, but I have a negative 1 out front, so that's going to be a negative. If I multiply, I get negative 448x to the 6th. Then we go 21 times 32x to the 5th. It's negative 1 squared, so it's going to be positive on this one. I multiply that, I get 672x to the 5th. Next one, we go 35 times 16x to the 4th, but it's negative 1 is to the 3rd. It's odd, so that's going to be a negative. So that's minus 560x to the 4th. 35 times 8x to the 3rd. It's negative 1 to the 4th. That's positive. We get 280x to the 3rd. Then we go 21 times 4x squared, and that will be negative. That's negative 84x squared. Our last term, or second to last term there, would be 14x and positive. Minus 1 is our last term. Notice on these we alternate positive to negative because we do have that negative 1 as one of our terms, so it does change as it goes from odd to even on exponents. And we have all of our values there. Notice x did count down. We have all of our terms. It's all pieced together. Okay, I think we have one more here. 2x plus y squared, and that's to the 4th. Now this is the first one we've actually had a y squared, or one of our terms on the inside is squared. This is going to change the way our exponents are written so that we can't look to combine, and it makes it a little bit bigger. But if we stick to the same rules, we'll be fine. So to the 4th, we know that's row 5. So we have 5 terms, so that's 1, 4, 6, 4, 1. I'm going to do 1 times 2x to the 4th, then times y squared to the 0. We don't need to write it. 4 times 2x to the 3rd, y squared to the 1st. 6 times 2x squared, y squared squared. we go 4, 2x to the first, y squared to the third. And then last one is 1, 2x to the 0, y squared to the fourth. Okay, we go back to put it together. 2x to the fourth becomes 16x to the fourth. If we have 4 times 8x to the third, y squared looks like our next one. This becomes 32x to the third, y squared. Our next term is going to be 6 times 4x squared times y to the fourth. Put that one together is 24x squared, y to the fourth. Our next one will be 8x, y to the sixth. And last one is y to the eighth. Now, this time our x's did count down, and our y's actually increased 2 each time, which makes sense. Instead of increasing 1, it was y squared, so it went 0, 2, 4, 6, 8. Okay, and there's our expansion there.